In this lecture, we will look at the principle of superposition of electric forces, and we will work out a example. First, let us read out the principle of superposition. It asserts that the force acting on one charge due to another is independent of whether or not other charges are present, and therefore we can calculate the force separately for each pair of charges and then take their vector sum to find the net force on any charge. Let's break down this statement a bit further. Consider three charges Q1, Q2 and Q3. For the sake of simplicity, let us choose all charges to be positive. I want to calculate what is the force on Q1 because of Q2 and Q3. Principle of superposition of electric forces states if we want to calculate the force on Q1, let us look at pairwise. Q1, Q2 is one pair, and the force on Q1 because of Q2 is repulsive, as shown by this arrow. Let us label this arrow. When we are calculating this force, notice how I am ignoring the existence of Q3. Similarly, when I am calculating the force on Q1 because of Q3, it is repulsive, it is in this direction. Notice once again, when I am drawing the arrow for F13, I am ignoring the existence of Q2. Finally, the net force on F1 is the vector sum of F12 and F13. Though we have looked at a very simple example consisting of two charges, or rather three charges, it can be immediately generalized to a system of n charges. Now let us look at an example to cement this idea. On your screen, you can see there are four charges. They are placed at the corners of a square, and we have been asked to calculate the net force on this particular charge. So let's do that. We apply principle of superposition. Let us label these charges for the sake of convenience. I want to calculate what is the net force on 3 because of charges 1, 2 and 4. Let's look at the force on 3 because of 1. Since they are unlike charges, the force will act along the diagonal connecting charges 1 and 3. Let us label this arrow. It is F13. Notice how I am ignoring the existence of 2 and 4. Now let us look at the pair 2 and 3. Since 2 is negative and 3 is negative, there is a force of repulsion as shown by this arrow. 3, 2. This should be 3, 1. Now let us look at the pair 4, 3. Since it is plus, 4 is plus and 3 is minus, there is a attractive force as shown here. F3, 4. So the net force on 3 will be the vector sum F31 plus F32 plus F34. Let us calculate each force individually. Let's look at F31. F31 equal to 1 by 4 pi epsilon naught K. Then I have 1 and 3. Q. 3 is 2Q divided by 2A square. Why is the distance 2A square? The reason is because the length of the diagonal of a square is root 2 times A. Furthermore, notice when I am writing charges Q1 and Q3, I am not including the sign of the charges. Similarly, it is a trivial matter to write F32 is equal to K Q 2Q divided by A square and F34 equal to K 2Q times 2Q divided by A square. F31, F32, F34 are just the magnitudes. They are not vectors. So let us include that information now. We will start with F31. Notice F31 needs to be resolved into X and Y components. So let's write the X and Y components. This is the X component F31X and this is the Y component F31Y. But what is F31X and F31Y? It is very easy. Complete the right angle triangle here. This is the right angle triangle. F31 is the hypotenuse and F31X is the base. If this angle is theta, then F31X equal to F31 cos theta. Similarly, F31Y equal to F31 sin theta. Here, of course, theta equal to 45 degrees because it is a square. Now that we have resolved F31 into horizontal and vertical components, let us add all the X components acting on charge Q3. So let's do that. F3 of X, all the forces acting in the X direction equal to F34. Let us put a minus sign. The minus sign indicates that F34 is pointing in the negative X direction. So basically what we are saying is the origin of the Cartesian coordinate system is fixed where charge Q3 exists and all arrows pointing to the left are chosen to be negative. With the same logic or similar logic, minus of F31X. Now let's look at all the Y components acting on charge Q3. F31Y is in the positive direction, so therefore F31Y with a positive sign, and F32 is in the negative direction, it is pointing downwards, therefore minus F32. Let's substitute F31X and F31Y. If we substitute, we will get F34 minus F31 cos theta. Similarly, here F31Y but F31y is F31 sine theta. So let me strike this out. F31 sine theta minus F32. So let's collect all the terms and write it in a vector form. Let me choose another blank slide. So the vector sum of all the forces acting on charge 3 is equal to F3x in the I direction plus F3y in the j direction. Substituting F3x and F3y. So F3x is minus F34 minus F31 cos theta, F31 cos theta in the I direction plus F3y. What is F3y? F31 sine theta, F31 sine theta minus F32. This is in the j direction. Now, for the sake of brevity of this lecture, I suggest you substitute the values and simplify. This gives the net force on charge Q3 because of charges 1, 2 and 4. For homework, I suggest calculate the net force on charge Q1. Similarly, you can calculate the net force on charge Q2. And finally, you can calculate the net force on charge Q4. If you complete all these problems, you will be gaining a very good understanding of the principle of superposition of electric forces. At the same time, you will also gain confidence on how to resolve vectors and how to add vectors.